What's been remarkable about the shift to critical metals is the shuffling of upstream and downstream. Our guest knows these moves well. Christopher Reed is Managing Director, CEO of Neometals. Neometals has business lines in downstream lithium processing and recycling. Neometals is also advancing mining projects. Christopher, welcome back to Kitco.
It is indeed my pleasure, Michael. Good to see you again.
Christopher, let's start about origins. Maybe you could start about how you found yourself to critical metals. You made some key investments early in this cycle.
Yeah, actually, probably well before this cycle. Yeah, so look, we transitioned from hard rock gold mining into, acquiring a hard rock lithium asset in 2009. We built Mount Marion with our partners, Mineral Resources and Ganfeng, into the world's second largest source of hard rock lithium production. We started that in 2015. In 2016, the board was like, well, what's next? We wanted exposure to a lot of these battery materials, and we found that the best way to do that was to recycle consumer electronics and EV batteries.
There is a number of businesses, so let's start with battery recycling. We did have an interview almost a year ago. So looking at what has happened in the battery metal space, big new developments, I would say, that would be the government support that has been out since that time. You would see most notably the Inflation Reduction Act. What's been the impact upon recyclers?
Yeah, well, look, I can sort of speak more around Europe, which is where our operations are sort of focused in Germany. Certainly, the EU battery regulations have been, and finalisation of the legislation has been the biggest change in the last year. They're creating Fortress Europe, mandating high recycling recovery rates. That's been a challenge. Have had to innovate and to increase our recovery rates to achieve the new targets in 2030. There's going to be carbon footprint declaration, minimum recycled content in new batteries. Um, you know, Lithium is the most valuable element that is recovered in battery recycling. Unfortunately, the share prices, I guess, of the recyclers have followed the lithium price down. It's now trending back and we've got to remember that we're in a channel. The highs are getting higher and the lows are getting higher, and we can sort of speak to that over the last 15 years. Recycling produces lithium at little to no cost because you get co-product credits for nickel, cobalt, copper, and aluminium. So, fortunately for us, and the lithium price is not correlated with the growth in the cell production.
When I talk to battery recyclers, they seem to emphasize one of two things. That's either a scale or tech. Is that fair? And also, where does Neometals fall, Chris?
Yeah, look, I think you've always got to prove the technology first, right? You've got to have a feasible solution. And then you must have a solution to scale up to meet the forecast demand. So, we've run multiple demonstration plant trials in Germany, and we'll continue to do that into the future as we, test different customers. They've got different formats, different cell chemistries. We recently announced our interim recoveries, and that'll meet or exceed the 2030 EU requirements. I think our solution for scale is in the selection of our partner in the business. SMS are a 150-year-old German plant builder with over 14,000 employees, with manufacturing facilities in Germany, the US, India, and China. And the only thing these little Germans like more than building lots of 50-ton plants is building lots of 500-ton-a-day plants.
Now, going back, you made your money in lithium with Mount Marion, and I also kind of think of Australia magnate Andrew Forrest, who made his money in iron ore. You're both embarked now upon green tech. Can you build a manufacturing center, though, in a resource country like Canada or Australia? I think about your Pilbara, for instance, that is investing in lithium processing in Korea.
Yeah, well, look, that's probably the only time anyone's ever said Andrew Forrest and myself's name together in a sentence. The difference is only he's the richest man in Australia and I'm not, by a long way. So, I would say that it's tough. Our partner in our battery recycling business has got the right to build all the plants that we want to build for our customers. And so, like I said, their manufacturing headquarters are in Germany, USA, India, and China. And we can build any size, anywhere, and any time. I doubt we could do that. We could do that in Australia as cost effectively as we can in other parts of the world. I think it's one of the things that's not well understood. About developing critical minerals assets or building the technologies around them is that there's only a certain set of skills and skilled people.
Two worries about critical metals. First would be a substitution. Tesla's dropping rare earth out of its cars. BYD is mass producing sodium-ion batteries. Is there going to be materials, just think, that are going to be recoverable or worthwhile economically recovering batteries as these things progress, Chris?
Well, I think one of the challenges for lithium as an industry is actually to produce enough product to meet forecast demand. Am I worried about these cell chemistries and substitution? Not really. It's taken us 30 years for the lithium-ion batteries to get where they are now. They'll be the dominant chemistry for EVs for the foreseeable future. Benchmark Minerals Intelligence, they're tracking 387 gigafactories in the pipeline to produce about 8.8 gigawatt, 8,800 gigawatt hours of lithium-ion battery cell capacity in 2030, right? And so, that's production scrap from those plants, and then the end of life. And when you have a look at the end of life volumes, McKinsey expect that demand for recycling will grow from just under sort of 2 million tons in 2030 to over 20 million tons in 2040. So, when you're a recycler, if they stopped producing lithium-ion batteries tomorrow, we would still be recycling lithium-ion batteries at end of life in 2030 or 2033. 10 years later.
Other concern is that Western automakers are rapidly losing share, especially like in the Chinese markets, and also China, given, its head start, given also its tremendous scale that it has there. It is going to start exporting autos. Are Western car companies going to be able to compete? Because, you're partnered with a lot of them, Chris.
Yeah, look, China produces 80% of lithium-ion battery cells in the world today, and it'll still be that percentage in 2030. They secured key supply chains of lithium, nickel, and cobalt throughout the last decade. Western car makers face an existential threat. They can build gigafactories and they can build EVs, but what's the utilization rates? Will they actually ever run them at their design capacity? Fortunately, Linda Gaines at Argonne National Laboratory in the US, has done some work and opines that recycled lithium can overtake mined lithium before 2040, and that is fantastic, and a great outcome for the industry. But the challenge now lies in bridging the gap between now and 2040.
Christopher, lastly, just on recycling, and I'm interested kind of on your take on what you see is going to be happening with the recycling future, the way that you manage it, say, a decade out. Neometals has taken a focus on Europe. We've seen some tremendous investment that has happened into the recycling space. So I think of like Redwood and Li-Cycle, and you see numbers in the hundreds of millions that they put into developing that. What do you see the shape of the industry many years out, and what is going to be, what is the advantage? What is the particular piece that Neometals is focused on?
Yeah, well, look, the companies you mentioned, they are recyclers, but they're operating as principal. And you get the others like Glencore and Umicore, and they're recycling because they need to secure feed for their downstream cathode making, or indeed having recycled content and lowering the carbon footprint of products that they sell to their customers. So these guys buy batteries and then they sell or use products. the battery, we look at a typical NMC 811, there's more than 8,000, sorry, there's more than 10,000 US dollars per ton that you can recover in value. Now, the car makers and the cell makers don't want to sell batteries for 2,500 a ton, right? They want their own materials back. They're facing, for every ton that they don't get back through recycling, they have to compete in a primary market that's going to be in deficit. So, our solution is to supply them their own plant and they can recover that $10,000 a ton. They get their products, their battery materials at the lowest quartile costs and with the lowest carbon footprint. And they just have to pay us a 10% royalty for the privilege, and we've already signed 4 licenses already. So, I think there will be people that, and look, we can provide recycling as a service if they want to. We can joint venture if they want a plant, but they want us to operate it. We can look at that. But our biggest challenge, we've never been worried about the supply of cells. It's who owns the supply, and the car makers will have the end of life, and the cell makers will have the production scrap. And the car makers are going to are going to be cell makers. So all roads lead to the car makers. So we listen to them, what they want. We can give them. We can actually remove recycling as a cost, which it is now, to actually a revenue stream.
How did you end up with the European focus, Chris? You did recently list on the LME.
Yeah, so like I said, when we were looking around for strategic partners, the bottleneck was going to be who can build the capacity, right? Because you can't ring up Lysical or Redwood or Glencore or Umicore and they'll come along and build you a plant, operate it, and give you materials back, right? That's not how they work. And so we went into Europe with SMS because the EU was sort of 2 to 3 years ahead of where the US in terms of the maturity of its transition to EV and cell production. The IRA has been, a fantastic shot in the arm for North America, and the forecast now is that the US will overtake Europe in 2031. But until that stage, Europe will be a big market. And don't think we have forgot about North America. One of our licensees is Stelco. For end-of-life car recycling in North America. And, we're hoping to offer them a 50-ton plant later in the year and to buy into the joint venture with them. So we certainly haven't forgot about you. We just started in Europe first.
Let's start with your other business, Chris. That would be the vanadium recovery project. What is it?
Yeah, so that one, vanadium is certainly an emerging battery technology for stationary energy storage. So you have the vanadium redox flow battery. CRU have forecast demand for vanadium to grow by 400% between now and 2040, which is fantastic. The Chinese are really driving it. 2 of the large vanadium battery makers there, Linyuan and Beijing Xincheng, announced new investments to increase the capacity of their output in terms of the battery modules that they make. And we've got 2 of their projects are going to use 20 and 33% of global production in 2025. So it's certainly an exciting commodity. In terms of our project in Finland, we're going to be using steel slags from sort of domestic iron ore up in Scandinavia, and we've got access to the world's highest grade vanadium feedstock, right? We're buying it off a reference grade of 3.9% vanadium pentoxide, which is a multiple of in-ground ore concentrate. And we're producing sort of military spec material that can go straight into the batteries because we've developed a very environmentally friendly process, create an inert tail, and a very, very low carbon footprint. So that project, we're currently in the project financing stage for that. We've got all the environmental approvals, and we look to kick that off later in the year.
Now, Chris, does that help with the steel production in terms of, because I know everybody's trying to move to a low carbon steel output?
Yeah, look, I think there's not that much vanadium. There's only pinches of vanadium in terms of what its input into steel. So it would reduce the carbon footprint of the steel only a small amount. What it'll really do is help the stationary energy storage battery. A typical ton of vanadium pentoxide from South Africa, Russia, China that's gone through the traditional flow sheet has a carbon footprint of in excess of 30 tons of CO2. We're looking down at 4 tons if we use bought CO2. And if we capture it from the local biomass power station, we'll end up with a negative carbon footprint.
Briefly, Christopher, but what's the niche that vanadium is kind of carving itself out for in energy storage? I mean, because there just seems to have been like a plethora of tech out there. Your sand batteries, pump storage, hydropower. What do you see the uses for reflow?
Yeah, so the vanadium redox flow batteries, I think the Chinese are now pushing, for no lithium into the stationary energy storage. You've seen the sodium-ion batteries you mentioned earlier. They're perfect for stationary energy storage, but for really, really large volume, you're storing the electricity in a liquid, so it's chemical storage of electricity. You can receive a variable strength current, draw out a constant. You can do them at the same time, charge and discharge. And we expect the vanadium electrolyte to last 30 plus years.
Going upstream, talking about, I think we'll finish on one of your last pieces of business, and then that would be Barrambie. You had announced a feasibility study for it last month.
Yeah, it's the only hard rock mining asset we've got left in Australia. My family's been hard rock miners for 4 generations. But look, Barrambie, it's the world's second highest grade hard rock titanium deposit. We've got a term sheet for the largest offtake agreement to a single customer in the history of titanium. It's the most advanced development project, and hopefully we can have it into production in a couple of years.
Lastly, Chris, turning to lithium, where we started at the beginning of this interview. You've been looking at the sector for a very long time. What are some overlooked key developments?
Yeah, look, lithium is just unbelievably exciting. The supply's got to go from about 350,000 tons of LCE last year, which has taken us 30 years to get there. And it's got to be 2 million tons by 2040. I think the overlook factor is it takes you sort of on average 7 years to develop a hard rock mining asset. I can attest to that. History in South America show that, from the start of constructing a brine asset through to steady state operation, it takes you 7 years. Doesn't matter whether it's La Negra 2 or a Cobre, what have you. And the checks to enable the production that we're going to need in 2030 just haven't been written. The IRA will accelerate that, but money doesn't buy time. The other thing, I guess the other soft spots in the whole story, or the challenges, are the pool of skilled labor, and we've seen Lithium Americas, put together a great team that have come essentially from Livent, or the old FMC, Albemarle and SQM. Where do the next guys get theirs? Because SQM, Livent, and Albemarle not going to be wanting to lose too many more people. And then the reagent supply. So, we've fortunately generated a solution that we haven't touched on today, but I'm sure we can touch on the next time once we've finished our pilot plant, which is ongoing in Lakefield, Ontario, for the purification, and then we'll be running the electrolysis in your hometown. So maybe when I get to Vancouver, I can take you out and you can have a look at it.
Well, let's talk about it, but let's frame it as this, Christopher. Just talking about developments in the lithium space. Elon Musk was asked about lithium supply, and then they said that it's a problem of processing. But if you talk to other people in the industry, they say it's a problem with mining. What's the issue, Christopher?
Yeah, well, look, 2/3 of the world's lithium resources are in brine deposits, right? Now, the Chinese have developed the hard rock conversion, and the Australians and the Africans and the Canadians all breaking our necks to be slaves to them, to sell them little white rocks. For brine, the bottleneck is conversion capacity from the lithium chloride that exists in the ground to lithium hydroxide or carbonate. So, we've developed a process that can purify and take a salar concentrated brine through to something that we can put in an electrolyzer. An electrolyzer or a chloralkali cell turns sodium chloride into sodium hydroxide, and this time we're just going to change the feed. Sodium, potassium, and lithium are alkali metals. They all behave very, very similarly in a chloralkali plant. And we've put out an engineering cost study, AACE Class 3, that shows that our technology operates at about 40% of the conventional flow sheet costs, and that you don't need reagents. And indeed, we make our own reagents, our own lithium carbonate and hydroxide to use instead of sodium carbonate and sodium hydroxide. And renewable energy is our biggest input.
Christopher, thanks for speaking with Kitco.
Thanks so much, Michael. It's been a pleasure.
My name is Michael McRae, and you're watching Kitco Mining.